Distributing with these a little bit more complex factored form quadratic functions is a little more complicated, but it's not too bad. So when we do these, you're still using that FOIL approach. So first, 3x times, and this example isn't one of the problems in there, but 3x times 2x gives us 6x squared. 3x times 1 gives us just 3x. Negative 6 times 2x gives us negative 12x. And negative 6 times 1, the last in each of the binomials, gives us negative 6. And then when we simplify these, we get 6x squared. There are no like terms to combine there. But we combine the 3x minus 12x. Those are like terms. So we can combine those into negative 9x. And negative 6 doesn't have any like terms, so it stays the same. So that part's not too bad. The coefficients on the x terms in each binomial are just bigger, but it gives us a little bit of a gnarlier quadratic function. The thing that gets a little bit tricky, though, is basically just finding the x-intercepts. That's the part that gets the trickiest, because we've got our y-intercept here. So that's our c value. And so that's the y-intercept, so that gives us a y-intercept of negative 6. And when you're doing these sketches, don't worry about, I'm just kind of eyeballing, don't worry about not having a grid. I'm just kind of eyeballing where there are. So I'm going to put my negative 6 right here. So that's our y-intercept at 0, negative 6. The fact that it has a b value of negative 9, remember, that just tells us that we know that the vertex isn't centered on the y-axis. So it's going to be shifted to the side, it's going to be shifted up and down. It's not going to be centered on there. The other piece that we want, though, are the two x-intercepts. And then remember, the x-intercepts are going to help us find the x value of the vertex, and then the x value of the vertex helps us calculate the y value of the vertex. So remember, the x-intercepts are the x values that make each of the two binomials equal to 0. So there's actually a little algebra problem that we need to do for each of these. So for example, for this first one, 3x minus 6, we're trying to figure out what x value makes that expression equal to 0. So we're really just solving this equation for this one. So remember, that means we're going to add 6 to both sides, then we're going to divide both sides by 3. So one of our x-intercepts is at positive 2, because if x is equal to 2, 3 times 2 is 6, and 6 minus 6 is 0. It makes the first binomial equal to 0. It doesn't matter what the second binomial is equal to when x is 2. Anything times 0 is 0. So we know that one of our x-intercepts is right here. Again, I'm just eyeballing this. And then to find the other x-intercept, we'll solve the other binomial for the value of x that makes the expression equal to 0. So 2x plus 1 equals 0. We want to solve that for 0. Subtract 1 from both sides. Divide both sides by 2. And we get x equals negative 1/2. So that other x-intercept is going to be right real close to the y-axis, right there at negative 1/2. So we've got one of them at 2 and one of them at negative 1/2. And so I can actually do a sketch of my parabola now. Notice how the two x-intercepts aren't centered on the y-axis. They're shifted a little bit to the right. That means our vertex is also going to be shifted a little bit to the right by that amount. So I can sketch it and eyeball where this would be, because that's going to help me kind of double check my work when I'm calculating the values of the vertex. But I know my parabola is going to do something kind of like that. Not the best sketch, but it'll work. So now what we want to do is try and figure out what the vertex is. We want to know what this point is right there. So remember, the x value of the vertex is the point directly in between the two x-intercepts. So between x is 2 and x is negative 1/2. So first of all, what you want to do is you want to figure out the midpoint between those two. So first you want to find the total difference between those numbers on the number line. So they're 2.5 units apart. If your numbers were messier, you could calculate this. If you're looking for the difference between two numbers, difference in for subtraction. So we could do 2 minus -1/2. And remember, minus a negative is the same as addition. So to get the difference between those, you actually add them together and you get 2.5. So those 2 points are 2.5 units apart, and we know that the midpoint between them is exactly centered between them. So you're going to go an equal distance from 2 down to the x value of the vertex as you would go up from -1/2 up to the x value of the vertex. So what we can actually do to figure out what that difference is, figure out how far from each x-intercept it is we can take 2.5 and we can divide it by 2. So whatever the difference is between the two x-intercepts, if you divide that distance on the number line by 2, you get the distance of the x value of the vertex from each of the x-intercepts. So this would be 1.25. So what that means is whether I go from this point plus 1.25 units, or from this point minus 1.25 units, I'm going to land on the x value of the vertex. So if we do, let's say we do 2 minus 1.25. And you could just put this into decimal form if you want to use your calculator, but this would be 1 3/4, or 1.75. So that is the x value of the vertex. So we know that that point has an x value of 1 3/4, 1.75. And then what you could do is put 1.75 back into either form of these two equations. You could put it into the factored form or you could put it into the standard form. Remember, those are equivalent expressions. And so if you put the same x value into both of them, you're going to get the same y value. And that would give you the y value of your vertex. Just to double check it, once you do that though, and you put 1.25 into your equation to calculate the y value, make sure that it makes sense. Because this parabola is shifted a bit to the right and down a little bit, the vertex should be below -6. Make sure that it makes sense. And then you can double check what that y value is by putting the equation into Desmos for all of these. If you put the two equations into Desmos, they should line up with each other. That means that you've correctly distributed and made an equivalent expression. And you can double check all of your points, x-intercepts, y-intercept, and vertex, and make sure that you did that all correctly.